And then I will review for the, although we're kind of going to do a little review at the very, very beginning. But I'll also review at the, or maybe we'll just do the review at the end. Yeah, we'll do the review at the end. That's fine. I did a little review at the beginning of what we learned, but we'll just do it all at the end for this class, so we can get into the new material first. So, what's the 2 on that 7 with the little tiny 2 up there? What do we call that? Exponent, right? So that's what we did last. Who was not here last class? Anybody? No. Everybody's here. So it's called an exponent. Let me set the timer real quick and make sure we start the review. So we'll say. I start the review after that. We should be good. So we said the 2 was an exponent. I said at first big number, but then we said the big number was really called what? The base. So that's going to be very important today because the new material we learn, I'm going to be using the word base a lot. And then exponent, obviously you have to use that since the lesson is about exponents. What does 2 or 7 raised to the second power equal?
7 times 7.
It is, that's what it means. It means 7 times 7. So I had a few people that weren't sure, but if I say, oh, yes, it's recording. I know that, but I had to change it there first. So if I say 7 raised to the second power, or we also call that 7 squared when it's a 2 up there, that means that I take the base, so this number, the big number, the base, and I multiply it times itself, and I do that as many times as I have in the exponent. So in this case, I just do it twice. Does not mean 7 times 2. So some people do that still. It means take that base number, multiply it times itself. Again, as many times as you have on the exponent. In this case, it's just 49, just twice. All right, so that's what an exponent is. It's a shortcut to multiplication, we said. Instead of multiplying the same number over and over and over again, I can just use this exponent thing and raise it to an exponent. All right, so let's pass out what we're doing today for your lesson. I've already printed something that has the main formula stuff, the rules on it. So you can just add some notes to it. That'll save you a little time. So you'll notice at the top, we already did that. In the other classes, I went over it. I'm going to come back to that at the end, so keep this out for the whole. Actually, you're going to, yeah, keep it out. You probably have it in your notebook also. Yeah. So I want you to just skip down to the line that says algebra. So just like right in the middle, it says algebra. That's what we're going to be working on first. This will not be on today's exercise. It'll be next week. Good grab. All right, so we already learned kind of sort of 2 of these without really knowing we were learning them. So look at the, not the first one, look at the one that says product of powers. Product of powers. It's on the line that says algebra, the middle line that says algebra. Keep going to the right until you see the one that says product of powers. Yep, I believe that is the one. So it says this, and again, they use A and M and N, so I'm going to go over what all this actually means. So it says that, but you got to know what that means. Not enough to just have a formula in front of you, you got to understand what it means. So what's it mean? What do you think that means? What do you notice about that? Tell me something you notice about it. Like just visually, what do you see? What stands out? Tejan, what stands out? There's all variables, first of all. So remember, a variable is just a missing number. Sometimes you'll have variables in the problem. You do the same thing with the variables you would do with numbers. Now, if you have m plus n, well, you can't combine those, so it's just the m plus n. If you have 3 plus 2, then you can combine that and get 5. So sometimes you'll have an answer that has variables in it if you have variables in the problem, because you can't sometimes do anything with the variables. But you still do the addition. It's just m plus n is just m plus n. We can't do anything. So it's still this plus that, just like it's this plus that, but now you can solve that and get 5. So that's the first thing. I noticed that there's a bunch of variables in this. What else do you notice? What about the variables?
They're not x and y.
Not x and y. So again, we normally use x and y for graphing, so they try to avoid those sometimes in other topics. Because we have an x-axis and a y-axis. What else? What are they called? We know what some of them are called. Just because they're variables doesn't mean they have a different name. You just literally did it. Yeah, there are exponents in there. What are the exponents? M and n are exponents. They are raised higher than the base number, the big number. So a is the base, by the way. So they are raised up, which means they are representing an exponent. So they're variables, but they're still representing some unknown exponent. What do you notice about the a?
It's also a variable.
It's a variable. We already kind of said they're all variables.
Base.
It's the base. We kind of said that too. What about it, though?
It's a times a.
So does it ever change?
No.
Do we ever change that base in this problem?
No.
That's huge. That is extremely important for you to understand. First of all, this rule only applies when you have the same base. If I don't have the same base number, none of the stuff we're doing today applies. So that's the first thing you got to understand. You have to have the same base. That's what having the same A represents. Not the same A, having A in both places. Have to have the same base for all of these rules that we're doing today. What else do you notice about the A where it doesn't change also? It's got to be the same here, but where else is it the same? I think that's right.
The answer is a.
And the answer, we don't change it over here either. It's still A. We do not. I was going to show you a number example in a minute. So, what does it mean that we're doing? So this is a term. We talked about what a term is. This is considered a term. It's a number. This is a number. It's an unknown number, but it's a number. So those are terms. What are we doing with those two terms? We are. That's what that dot means. We're multiplying. So here's the next thing you need to know. This is specific to this one rule. Product. What does product mean? What's product? To what kind of problem? Not addition. It's the answer to a multiplication. That's why we have a multiplication symbol here. So here's your next note specific to this one. This is only for a multiplication problem. Now we wind up using addition for the answer, but the problem itself, the original problem, has to be multiplication. So here's your full note. I'm just going to tell you what's wrong. So you use this product of a powers rule when you are multiplying. I don't think it explains anything in words in here, right? Yeah. No. So you use the product. So this is the third rule, not the first rule, if you didn't hear me say that. So it's not the very first one. The first one says power of powers. We're not doing that. We're skipping over to the third one that's in the middle. You use this when you are multiplying numbers that have the same base. So you use product of powers when you are multiplying numbers that have the same base. So the rule is telling you, once you know you have that, multiplication and then same base, all you do is you add the exponents together. You keep the base the same, do not change the base, and you get m plus n. So our final answer would be whatever m plus n would be if we have two numbers. We just add them together, and that's our final answer, and the base stays the same. Everybody got it? Yeah, that's why I went ahead and printed it, so you can just take notes around that. So let's do a couple. What if I gave you this problem? And I said, and you would never multiply it all the way out. Like, I'm not going to ask you to multiply the same number over and over and over and over and over and over and over. Man, I got to change my rule. So if I give you this, I'll start with some simple ones. I want you guys to do that one. So write it down so you can take notes in your notebooks. You can just write a bunch of these examples on the sheet itself. We're going to do quite a few of them, though, so if you're going to write them on the sheet, you might run out of room. If you don't number your notebooks, it's kind of late for me to mention this now. Numbering your notebook pages, or at least putting the date, is not a bad idea, because then when you put examples on a different page, like a worksheet, you can refer to that date in your notes so that it's pretty easy to find and match stuff up. Oh, I forgot to get water.
Isn't the answer different now instead of like
Well, I want you to write it down. Just write it down. I don't want anybody saying last class people were ruining stuff by saying stuff out loud. I need everybody thinking about it. So write it down and we'll talk about it. Nothing out loud yet. I want everybody thinking about it. When people say stuff out loud, other people stop thinking about it. Because somebody just get the answer. So first of all, based on what we just said, we need to check and see if we can even use rules. So what do we have to check first? Have to have the same base. Well, we do. 2 is the base. So we have the same base. So that works, 2 and 2. So we do have the same base. What was the next thing we said we had to have? We're multiplying those two numbers together. The numbers that have the same base, we're multiplying them together. So we have everything in place we need to use the rule. So what does the rule say?
multiply numbers having the same that have the same base?
Well, that's what we need to have, but then what do we do then to solve it, to get the answer? That's what's on the right side over there. No. What are we doing? What is it doing literally in the right side? What's it say to do? A represents what? So what do we do?
Add multiply the base?
Do we?
No, it stays the same.
Yeah, what's on the right side over there?
3 plus 2, or x plus that.
Well, that eventually, but what do we need first before we just start writing an exponent somewhere? Can't have a floating exponent. So what do we need to do? Yeah, you gotta write 2. You gotta write the base. You gotta have a base before you can have an exponent. So we just keep the same number. We do not, and somebody's going to wind up doing this, guaranteed. We do not multiply the 2 times the 2 and get 4 there. That's not a different thing. That's A. It's A. You, in any of these rules, it's always the same base. You're never going to do anything with the base number. It's only the exponents that we're going to be doing math with, and the math will change depending on which rule it is. So then what's it say we do?
Plus the exponent.
So we take each exponent. So this would represent the first. Now, you might have problems where you got 10 different numbers with the same base and 10 different exponents, and you'd add all of them together. This example just has 2. But you would just add every single exponent if it's all multiplication and it's all the same bases.
Does it matter what the 2 are in order?
It's not really, because when you add them together, it's going to give you the same thing. But, I mean, technically, the way this is reading, 3 would be the M, 2 would be the N. So you'll get the same answer. But if they ask you an understanding question about one of those specific variables, then you need to know which one they were talking about. But I think you're fine on it. If you are asking that question, you probably understand. So that's your answer. That's it. We don't do anything with the 2's. We don't say 2 times 2. That's probably the biggest mistake. That's not the biggest. There's another mistake that's bigger, but that's a common mistake. All right, so any questions on that? I'm gonna get rid of all of that. So hopefully you got it all written down, because now I'm just gonna put some problems up and we're just gonna practice a few different problems. Again, this is not on the exit ticket today, so if you feel like you're behind, don't worry too much. We'll go back over this next week and get more into detail on it. All right, let's try. So still product of power, same thing. So what would this be? Do that one real quick. Actually, I'm going to put a few of them up here. Write them down. I want you to do all of these. I'll do 3. So do those 3. Again, I'll never ask you to actually multiply it all the way out and say, well, what would 3 times 3 times 3 times 3 times 3 times 3? I'm not going to ask you to do that. You're just putting the answer in a format that has a base and an exponent. Minute, and then we'll go ahead and start going over them. Make sure the more examples you have, the better off you'll be next week when we do that quiz. Actually, next week's still an exit to get the following week's big quiz. All this stuff will be on the big quiz, including what's on the exit ticket today. All right, what's the first one? Let's write it out like in baby steps, not just the final answer. It says to do what first? Who am I going to call? I'm going to call on Alexander. What's the first thing we would do, Alexander? So you don't need to. Oh, actually, you try it. So what would you do for this first one? What's the first thing you can do? The top one with the 3 squared times the 3 of the 6. Rule right here. This is the rule we're using. Should write that up. What do we do? You here last night. Here last night. I'm gonna call on somebody else. Luna, what do I do first? You guys got to practice on your own. When I call on you, I expect you to have something ready to say. I'll let you, Monty.
Base.
Yeah, that's the first thing. You have the same base. We can't do any of these things if we don't have the same base. So if you have the same base in the problem, you have the same base there. All right. Now what do we do? I'll go ahead and call you guys. Then we take the, now because we're multiplying and we have the same base, we can say, all right, well then I just need to add those 2 exponents. So my final answer would be in that format. Base of 3 raised to the 8th power. Next. Daniel, you can give me the answer to the next one. You have a final answer? What would it be? So if we added all those together, we would have 17 raised to the 16th power. We have the same base in every term. So we just say I can add the exponents. 4 plus 3 plus 2 plus 7. Well, that's 7 plus 2 is 9. 9 plus 7 is 16. All right, what's the next one? 2 is all, it's always going to be the same base. We don't multiply any of those bases together. 4 plus 3 plus 2, what'd you get? Do you have any questions about that one? I'll tell you right now, somebody should have a question. Sean. That's wrong. Why? Don't forget. So here's your next missing thing. This is the biggest mistake. I said there's one mistake that's bigger. This is it. There's an exponent on that. Just because you don't see one doesn't mean there's not a 1 there. There's always, if you have a number with no exponent, especially for this topic, which is exponents, just write it in. Maybe you don't wind up using it, but most of the time you will. So we should have said 1 plus all of those other ones, which means this would have been 2. There will still be people that will make that mistake all the way through the end of this. It's a common thing to do. You look there, you just take the numbers that you see and you just add them together. But if you get in that habit of writing a 1 in every time, then you'll see a number there and you'll make sure you include it when you add them together. Or if you do one of the other rules, you'll still need the 1 to do the other things you can do in the other rules. All right, so again, biggest mistake, next biggest mistake is somebody's probably going to wind up multiplying those together at some point. All right, that's really it for the product rule. Have to have the same base. You have to be multiplying everything together, and then you would just add all the exponents together. And it doesn't matter how many terms you have, you just add every exponent. All right, next rule. Let's do the quotient rule next, which is the last one, I think, the far right. Yeah, quotient of powers. So look at that one, the one on the far right. You don't need to copy anything down yet because it's got the rule there for you, so I'll write it. So, well, I'm just going to write quotient, but it says quotient of powers. I'm not going to write the of powers part. So what letters do they use? A, M, right, is that. So what do you notice about this problem right now?
Fraction.
It is a fraction, really. That's all it is, a number on top and a number on bottom. What else could you say it is? Besides, what is a fraction, really? We say in algebra, we consider a fraction this type of problem.
A decimal?
Sometimes we get a decimal as the answer, but what kind of math are we really doing? I mean, yeah, that's what I was looking for. We're doing division. This line means division. Anytime you have a line in between a top and a bottom number, meaning it kind of looks like a fraction, you're dividing the top number by the bottom number. That's really what we're doing. That's why we're using quotient to name it, is because we're really doing division. Quotient is the answer to a division problem. So we are taking this top term, top number, divided by this bottom number. Doesn't matter if there's variables there, it's still top divided by bottom. And then it says we do what for the rule? What's the end part of or the answer part of the rule look like? What's the first thing you notice about it?
What are we looking at? This right
The
here?
quotient rule. You have the far right one. What's the first thing you notice about the answer part of
It's
it?
a subtraction.
What's before that even? What would you notice? That's the exponents, but what do you notice about the base?
It's A.
Still A, right? We didn't change A again. A does not. I'm trying to drill that into your head so nobody ever changes it, but somebody still will. A never changes. The base is the base. Is the base, is the base, is the base. That's it. A. Now we can move into the exponents. What else do you notice about the exponents?
Huh?
What else do you notice about the exponent? Like, what are we doing with the exponents now? We're not adding them, right? So now we subtract them. So, kind of like multiplication and division are opposite, addition and subtraction are opposite. So if we added when we did the product rule, the multiplication rule, we're going to subtract when we do the division rule. And that's your answer. Take the exponents and subtract them. So let's do a couple with that. We'll do, we'll start out easy again. Right, so write down what that would be. There will be your first example of quotient one. Actually, I'll put another one up there. So you can do that one there. I'll put one in blue over here. Give you another minute to do both of those, and we'll go over them. We're gonna go. If this is not part of the exit ticket, so I'm not super out. Next week is when I'll be walking around and checking. Today I'm mainly concerned about what's on the exit ticket. The exit ticket frankly is not that hard, and there's not much more to do on it. So I figured we'd go ahead and start some of these. All right. So it looks like most people are done. Have wrapped it up. So what do we do for this one in red? Again, always keep the base. Like that's something that, again, you should just drill into your own head. Keep the base, keep the base, keep the base. Never going to be different. So what would we do with the exponents?
7 minus 4.
So final answer, just 2 to the third. So what about the one in blue?
Keep the base.
Keep the base.
Even if it's not an exponent, there's a 1.
So that's another thing. Even before you did keep the base, you could write a 1 in. So now what?
5 minus 1. And then it's just.
And then I'll write it down here since I'm kind of running out of room. But yeah, we just subtract the exponents. Let's do one more of that. Actually, 2 more of that because I want to also do one with the variables. So I'm not sure I can make it a whole lot. Let's do. Oh, I know what we'll do. What's that one? It doesn't matter if you have you could theoretically even have a fraction as the base. And if actually you definitely will have fractions as the base and then that raised to an exponent, so you still just keep the base and then I'll put one over here while you're finishing that one with variables. We'll say m raised to the kind of combining 2 things into that one. All right. So what do we get on this first one over here? We just said part of it. So what do we do?
Keep the base.
Keep the base. Then we would be doing what?
3 minus 5.
Ooh, somebody did do it right. It is 3 minus 5. I hope nobody put 5 minus 3. That would be wrong. So you may want to go up and make a note if you did 5 minus 3. Top number subtract bottom number. Bottom exponent, I should say. Let's make it exponent, not number. So if you made that mistake, you need to make some kind of a note so they don't make it again. It is always the top exponent subtract the bottom. Not the biggest one subtract the smallest one, which is what a lot of kids will sometimes do. So what do we get? Yeah, it's a negative exponent. You can have negative exponents. That's a whole another rule we'll get to next week. It's not even on this sheet, but we will get to it. You can have negative exponents there. That's the answer to that one. What about the one over on the right?
Keep the base.
Keep the base.
4 minus 5.
4 minus 4. It's 4 on the
Oh, I
line.
can't see from.
Yeah. So we get this, m to the 0. What's that mean? What in the world do we do with that? Not only is it a 0 exponent, it's a variable raised to a 0.
And we're just you taught us this
I
last
did
year.
teach you this, didn't I? And I told you I would explain more about it today. Just one. We can finish that. That's not a final answer. So again, on an EOC, they might put this, and they might say, select all of the answers that are equivalent. And you might see this as one of the answers, but you also might see this. You got to know that those are both equivalent. Anything raised to the 0 power, even though it's a variable, that eventually, no matter what number you plug in for that m, if it's then raised to the 0 power, it's going to be 1. So there'd be 2 equivalent answers, m to the 0 or just 1. So I told you I would explain why it's 0, like why something raised to the 0 power is 1. So we're going to do that real quick. Anybody still writing that? Everybody's got the 0 part? All right. So let's just go over that super fast. You don't need to know this, but
So do you put 1 up and replace 0 with 1?
we don't replace it. M to the 0 is 1. So you don't put the 1 up there. Some people do that. I'm glad you mentioned that. It is not m to, you don't change it from m to the 0 to m to the 1. M raised to the 0 power equals 1. Glad you said that. I didn't mention that last class. Luckily, that's on the recording since I didn't record first class. So, but that people did that a lot last year. They thought that, oh, that means I replaced the 0 with a 1. No, m raised to the 0 power is 1. So, what does it mean if I have, and we'll just do a pretty simple one, 2 to the 4th, 2 raised to the exponent of 4. What does that mean? What's it mean when we have an exponent? Oh, come on, we just did this. What's that? What does it mean? 2 raised to the 4th power means what? When we raise something to a... Yeah, it means we're multiplying the base, right? Same thing we did before. We're multiplying that base times itself, however many times we have in the exponent. Well, bottom means the same thing. So I'll do this 2 different ways. What's the top part equal? Well, let's not do it. Well, I'll do that second. What can I do now? Does anybody have any idea what I can do with that? Because what kind of a problem is it still? There's multiplication, but really it's a division problem. It's still a fraction, right? Don't we still have a number on top? We've broken it out some, but it's still a number on top divided by a number on bottom. So what can I do? Any idea? You don't get this part. Oh, it's not a big deal. I just want to see it. They got it in the last one. What can I do with those 2's? What? Hey, yes. We could. We're going to do that second. But before I multiply them all, because I want to make my math as easy as possible. What do you mean break it up? We could, but I'm trying to make my math even easier. There's an easy thing we can do in any problem where you've got terms being multiplied divided by more terms being multiplied, even if they're not the same number, really. What can you do with this? If that's a fraction, what can you do with that?
Simplify it.
So how would we do that? So how, like, tell me what you would get. Not times 2.
Divide by 2.
We could divide both of them by 2, right? And we would say, okay, well, 4 divided by 2 is 2. 8 divided by 2 is 4. But are we done?
Simplify it.
We could do more, right? We could divide it by 2 again. So we could just say, well, I'm just kind of canceling out by dividing each number. Oh, I didn't mean to do 2. Thinking divided by 2. So I'd simplify it down to 1/2. Basically, we're just saying what number can go into both of those. Well, let me ask you this. Is there a number that can go into both of those 2's, the first 2 2's? 1 could, whatever, higher number. 2. 2 goes into 2, right? So I could simplify, I could kind of think of these as individual numbers over each other, because that's really what they are. I could say, well, this 2 divided by that 2 just goes to 1 and 1. If you don't get this part, don't worry too much. I'm going to do it another way too. This 2 divided by that 2 just goes to 1 and 1. That goes to 1 and 1. That goes to 1 and 1. What am I left with? 1 over 1. What's 1 over 1 equal to? So we said this was equal to, because we say 4 subtract 4, right? Was equal to that. But it's also equal to that. That's why it's equal to 1. Anything raised to the 0 power, you're basically just saying you're dividing the same number by itself. Anytime you divide the same number by itself, it's 1. So that's why that rule works, or that's why 2 raised to the 0 power is 1. Because when it comes down to making a division problem, you're saying the same number divided by the same number. Yeah, now's a pretty decent point. So trade your, is the pass on the end, I hope. Oh, don't tell me I lost my pass. How did I not get my pass back?
What pass?
The bathroom pass.
They never come back with it?
I don't know. And I stopped as soon the day I stopped taking phones for it. Somebody doesn't come back. I'm trying to remember who. Oh, Aiden. Make him give me his phone. I don't believe him. Or he probably left it somewhere. And that's why I have to do it. So just leave your phone and go. I'm not writing one, so it drives me crazy. That's why we teachers get frustrated. The day I stopped taking phones, literally the class I stopped doing. I took them all the way up until him because they were done with their work and I was letting them use phones anyway. Drives me crazy. First person. So we could have also multiplied all the 2's out, just like I think Damani said. We would have gotten 16 over 16. Again, 16 over 16 is 1. So that's why 2 raised to the 0 power you can say is equal to 1, because it winds up being the same number divided by the same number. All right, so just be careful when you get a problem. You might also get this. I meant to do this one earlier. Sometimes you'll get numbers and the exponents might be negative. So you might have something like this. Doesn't change anything. You have the same base in all of those. You're multiplying them together. So what's the rule say that we do? Keep the base. Always keep the base. That's the first thing you better get right. At least you get some points for keeping the base every time, even if you get the rule wrong. Then what do we do? What do we do with the exponents in that case? Well, not subtracting. That's quotient. That's when we're dividing. We do subtraction of the exponents when we're dividing, like this. So look at your rule. What rule are we using now? We're not doing a problem where we're dividing. We're doing a problem where we're multiplying everything. So which rule? So if you need to make notes to get these clear, I printed the book rule out for you, but if you need to make your own notes, because this is not a division problem, a quotient problem. It's what kind of problem? It's multiplication, so which rule is based on when we're multiplying all the terms? Well, I'm asking you which rule first, not what we do. Find the correct rule, and then that rule will tell you what we're doing. First, you need to identify the correct rule. Then look at what the rule tells you to do. If we're multiplying terms together, which rule is it? Well, which rule? I'm asking you which rule. It's we've only done 2, so got one of the 2 we've done. It's not quotient.
Only got the third rule.
So what's the third rule?
Power of
That's the rule. So if you don't know what that rule means, you need to write above that rule. When we are multiplying things together with the same base, I told you to write that. I'd write it on the sheet though, because apparently you didn't match it up with the sheet. When you are multiplying numbers with the same base, that's the rule you use, the product rule. We're multiplying numbers with the same base. That's the product rule. Well, the order we did them in, that was the first one. But yeah, it's the third one on the paper. So we would take, but here's one thing, I'm not going to do this first. What did we forget?
The 1.
Thank you. Do not forget, because whoever was telling me was starting with the -3. Forgot the 1. So now we have the correct next step. Then we just add all of those together. 1 plus -3 would be -2. Plus 4 would be +2. Oh, it looks like we get 0. So we actually get 2 to 0. I didn't mean it to do that, but that's fine. So we could actually then say, once we got 2 to 0, we could even take it one step further and just write 1. All right. So we've done quotient rule. We've done, right, we're good on time. Done quotient rule, done product rule. So there's one more rule, and then we'll start the review and give you the exit ticket. Exit ticket only took some people like 2 minutes, some people 5 minutes. We're gonna do power of a power. We're not going to do the product of powers. Wait, no, I'm sorry. We're not going to do power of a product today. We're just doing power of power. So now look at the very first one. So it gives you, what is it, A? It uses A and the M and the inside. So again, this is the power of power, right? Is that what it's called?
Yeah, power of a power.
I just call it power rule because I call it product, quotient, and power. I don't like the of power stuff they put in there, but anyway. So now it says A raised to the M, but then it puts that in parentheses and it says, let's take that and let's raise it to a whole nother power. All of this raised to another power, which is the N. We actually did a problem like that yesterday, or 2 days ago. I'll show it to you. So what's it say we do then on the right for the answer part? I was going to say, somebody better say keep the base, because you're always keeping the base. And then you do what? What's it mean? I just wrote what it means. What does that M and N together mean? When they're next to each other, it means what I just wrote. Yeah, I wrote it for you already. Does it have the symbol or not in there?
No, it's not in there.
Yeah. So that's what M next to N means. Remember, 2 variables next to each other means multiplication. A number next to a variable means multiplication. So that's the same thing. They just don't show the multiplication symbol when it's 2 variables or a number and a variable. We don't show multiplication. We only show it between numbers. Why do we show it between numbers? Like we show it, we don't show the symbol between variables. Like if I write 2x, I don't show that that's multiplication, 2 times x or 2 times y. Why do I need to show it between 2 numbers? Yeah, if I wrote 2 times 3 and I just wrote them next to each other, you just think that's 23. That's why we have to show it between numbers. Other than that, we never have to show it. Because you clearly know that this is a different number than this because it's an unknown number. We don't know what it is. So that's the only reason we have to show it between numbers, is because otherwise you just think it was a one number. All right, so if we have a problem like this, what do we do? Everybody should be saying the same thing right now. Keep the base. There you go. Keep the base. Make a TikTok. Hey.
Please don't.
Keep the base. I gotta come up with a good song for it. I'll make up a song. Now what? Yeah, it says multiply these 2. Anybody recognize this problem? We did it 2 days ago. Not in the packet, but it was on the board when we did it. What did we say this means here? What did we say that means? Using our, just what's the definition of exponents? What does that mean? 2 to the 5th raised to the 2nd.
Oh, you showed us that.
We did that. What does this part right here mean when I take something and raise it to the 2nd power? It's a shortcut to multiplication, right? It means we're taking what's in parentheses, we said. Doesn't matter what's in there. Could be a whole expression with variables and numbers in there. We're taking what's in parentheses, multiplying it times itself, however many times we have for the exponents. What did we say that meant?
What?
This. We broke this down even farther.
I'll keep the base and then you do.
Well, we're not solving it. Just what do these mean? We broke those down even farther. Yeah, we said this means, well, the base times itself 5 times. And then we said, well, then that's times this base times itself 5 times. And we put multiplication in between all those. Oh, I did extra stuff. So we broke them down like that before we knew any of these rules. But now let's apply the rules we just learned. What are we doing here? What's the rule we're doing here, really? So keep the base. What's the math going on between those two numbers? So which rule is that when we're doing multiplication? Which rule do we need to look at? So which is called? So what's the product rule tell us to do? No, it's when, but the rule doesn't tell us to do that. That's how we find the correct rule. So we found the rule. That's, we don't do, you because okay, that happened too much. Let's go over that. There's 2 parts of it. You find the rule by seeing what you're doing. Once you know the rule, the answer, what you do is that last part. The part at the end after the equal sign. That's what you then do to solve it. So what's it tell us to do to solve it at the end? Like the A, the base, and then what did they do with the exponents? So you figured out which rule. You don't use multiplication though on this just to get the answer. What's the answer saying? The end after the equal sign, what's it say? For that rule. You found the correct rule, but now look after the equal sign, it says what? Daniel, what's it say after the equal sign? Did you put that sheet up? Oh boy. Bad sign for you next week.
What are we looking at? Power up.
You tell me, which rule are you looking at? You see again, I will not tell you which rule you use next week. Why? Because why? Exactly. We are multiplying numbers with the same base, so multiplication, same base. But then to get the answer, you have to look at, well, what's the answer to that type of problem? What does it say the answer is for that type of problem? It's in variables, but what does it say you do? You add what, though?
The exponents.
That's how you follow the steps. First, you got to find the rule by looking at the original problem. What's going on in the original? So here we got multiplication. Now up here, oh, I erased it. If we would have had this, here we would have looked for division. But once you find the correct rule, you have to look at what's on this side over here of the rule to see what you're supposed to do with the base. The base is always the same, you just keep the base. But you have to look over on that side where it's got the m and the n either being added or subtracted or multiplied. That's when you figure out how to solve it. The first part is identifying the rule. That's just based on how this side looks. Figuring the answer out, you got to look at the answer part of the rule. So the answer part of the rule, this is the rule that Damani just found. So now that I've identified this is the correct rule because we're multiplying and we have the same base, now I got to look over here. This tells me what to do. So I say, okay, well, I keep the base and then I add the exponents. A lot of kids got confused because they said, oh, well, I'm multiplying it. So this is the product rule, but they had written in, use this for when you multiply. So then they multiplied again over here. You'll never do it twice. So you, whatever notes you need to straighten that out, you know, I'll confuse you if I give you what I would probably write. We're doing it here. So again, we've identified the rule. Now we look at the right side over here. And okay, on that rule, in order to get the answer, we do that. We add the exponents. So that's how you have to use this. First you identify the rule, then you figure out, okay, how do we get the answer using that rule? And that's just what's on the right side of the rule. So again, we get 10 raised to the second. Same thing we got when we used this other rule. So this was, which rule did we use here though? Which one of those rules looks like this with something? That was power of a power. That's when we multiply the two exponents. And you'll notice we never do, like there's no rule where you do the same thing with the exponents. One rule you multiply them, one rule you add them, one rule you subtract them. You should never be doing the same thing in two different rules anyway. What do we need to do on this one if we're going to use a rule at bottom? So if you're writing all this stuff down, what is it? It is, again, product, right? We're multiplying numbers with the same base. So what do? Now you look at the answer part of that.
Keep the same base.
So we're going to keep the base. So what do? So what do? Still waiting for somebody to give me that. There, that's what I was waiting on. Don't forget, if you don't see an exponent, just write them in. Before you do anything else, every single number, write an exponent in for this topic. So now we could say, okay, well, I'm just going to add 1 plus 1 plus 1 plus 1, add it a whole bunch of times. Same thing as saying 1 times 10 because it's 10 ones. So you'll notice we got the same answer every time. If you just remember the product rule, you can actually use the product rule to solve every single problem. We used it to solve this because we just broke it down into this and we said, okay, well, I know in the product rule, I just add those two together. We use it to solve the quotient rule because we said, okay, well, if I have two numbers over each other, that's really just 2 times 2 times 2 times 2 over 2 times 2 times 2. Well, now I can cancel out these, so I'm left with 2 to the first power. Well, that's what 4 subtract 3 is, 2 to the first power. If you really just understand, you really just understand that product rule, that's the only one you need. You don't need to remember, because you're not going to remember all of these on the EOC next year. You're just not. I mean, you got so much stuff you're trying to take an EOC on. I'm going to really focus on this next week. And then we'll do the other ones fast, because in my class, you can just use your notes. So you'll be fine just using your notes to figure the other ones out. I would say if you're going to spend some time really understanding one, understand this, it'll get you through every exponent problem on the EOC. And obviously the goal, this class is just trying to set you up to pass the EOC next year. That's all this class is for. All right, let's start the, pretty good timing, we're actually 3 minutes early. Let's start the review. So get out your worksheet that we had last class that you should have already finished. If you weren't here, I don't actually, anybody not here last class? I don't have any of them, but there's some in the book. All right, good. Trayvon wasn't here. Trayvon. I'll get in the worksheet in a minute. So we took these notes. 1 more, 2 more, 3 more, 4 more.
Are we doing the 6 to 1 practice or the practice?
Both of them had the same problems. They were the exact same. I just gave you more problems. We took something in this format here, and we changed it into something in that format with just a base and an exponent that was a fraction. That's what half of your exit ticket is today. Same exact thing. But the other half is a little tiny bit different. So we're going to practice both of them. So as a reminder, I wrote this for you guys, right?
Yeah.
Because I didn't do it for second period. I did it at the very end, but it was only for like one person. So I had to go back through all of that for them. You guys have already done that, so I'm not going to redo that a whole lot. What I want you to try to do, there. I want you to try to do these 2 problems on your own first. Good shot. Those 2 first. So this one in blue, which you've already done, but don't look at the answer, just try to do it from scratch. And then the one in black. So try to do those 2 real quick while I clean up some of these missed shots. So that. Well, that's why we're doing the review. And I didn't want to do the review first and then the new material, because then you probably forget about it. It's pretty easy though. There's not in the blue one, but again, it doesn't matter. You just use whatever is in the spot, and you use whatever's in that spot. If it's a number, you use the number. If it's a variable, you use the variable. Oh, I just made these up. Yep, no, I'm just telling you to do those. Oh, and you're changing it into a format where you have like a base number and then an exponent that's a fraction. That's the format you're moving those into, which is what I have up here. So this is the format I've given you here. I've given you that and that. This is the format you're moving into. Base, and then the fraction is an exponent. I don't want you to say anything yet.
Okay.
I want to see what people do, and then I'll let you answer when we're going over. Or ask, answer each other.
Wait, how is this?
Oh, I knew that was going to come up. Try it. I would just try it right now. Just try it. We're going to go over it. I don't want to just start telling you stuff. I want you to think about it. That's how you learn. Even if you make, actually, you learn more when you make mistakes than you get stuff right. You have a question while you're starting the so let me get you were not here last class, right? Come on. Let me get you a paper. Wait, I don't, oh, actually, did you get one of these when you came in? Were you already in here when I passed this out? You got one? So that's kind of got everything on it up at the top. You can write this note on there if you want. This is the same thing as all those A's and those M's. But I think it's a little easier to understand than that. You want to write that in? Pretty easy exit ticket, so I think you'll be fine if you want to wrap it up. All right, so let's talk about these. So again, same exact thing we did last class. Half of it. I mean, these are not these problems, but the same thing. You can do the same exact thing. So we need to identify. In this format, we need to identify where the stuff is and where it's going to go. We're just moving stuff around. No calculation. Just on the blue one. Don't ask any questions on the black one.
No, I don't have any questions. I just want to say anything.
Well, let me do something. I'm going to give one tip, maybe. Not really a hint, tip. If you're struggling on this, like you're just not a real strong visual person, just do this. Look at the format it's in. Shouldn't be hard to match it up because they're all different. One of them doesn't have any radical symbol, right? So that's pretty obvious to match up. One of them has a radical symbol but no parentheses, so that should be easy to match up. And then one of them has a radical symbol and parentheses. So there's something majorly different about each of them, so you shouldn't have a problem matching them up. So if I give you this, which format is it in out of those three? Can't really. Oh, yeah. Oh, yeah, it's right there. Which format is it in? This one down here is in which format? The first, the middle, or the far right? The middle. I circled the middle, so that's pretty good too. It's got a radical symbol, but no parentheses, so it's the middle format. So in the middle format, that's this. If you want to, just do this. Like, again, you have to write really small. Label this, because it's the big numbers right here, right? Well, label it big number. Well, top number's right there, so label this thing the top number. Bottom number's right there, so label that the bottom number. Again, I'm not going to take off if you don't do this, but if you're struggling and if you accidentally are putting stuff in the wrong spots, or you're not sure where to get stuff from, just take this map, this model, and when you get the actual variables or numbers here, label what they should be. Now, when you go to change it to that format, you just say, okay, first I need to find my big number. Well, literally, it's written right next to what you're going to use. So what's the big number? M. It doesn't matter that it's not a number. We take whatever is in that position, M. So now I come over here. Well, I need a top number over a bottom number. What's my top number?
1.
Well, that comes, no, not 1. N. Whatever is in that spot is the top number. So we write N. And then what's the bottom number? Well, whatever's in the bottom spot, which I actually just labeled, I write as the bottom number. So don't think because you have a variable that you don't have it, that's 1. It's whatever is in that spot. It's the exact same thing we did, or 2 days. We're going to do something new though in a minute. So now, What about that one over there? What do we have in that one over there? So if I labeled them, I could go ahead and label one thing. I could say that's the big number. I got that. What am I missing though? Yeah, both of the other two things. I'm missing top and bottom number. But we know where they go, right? So what should be in the spot?
The top number is 1 and the bottom number.
We said if you are ever missing the top number, it is a 1. If you are ever missing the bottom number, it is a 2. Always, no exceptions. And you won't be missing a top and bottom number if it's already in this format. There's got to be 2 numbers, or it could be variables, but again, you just use whatever is in that spot. So once you've written them in, now you can do what we just did. You can say, okay, well, that's my top number. That's going to be my bottom number. Now you just move them around. So the big number goes, so if that's the big number, I look over here. Well, I've already got the big number written there. So I need the big number. Well, it's labeled right there, 27. So now I need my top and my bottom. Well, I've labeled the one top. I've labeled the bottom 2. So there we go. 27 raised to the 1/2 power. Any questions on that? Now that's a review. We are going to change it a little bit. Not a lot. I'm going to get rid of what we just did though. So everybody's good, right? All right. So here's the last thing that's on there. So that's half the exit ticket right there, what we've already done. Here's the kind of sort of new, not really new. I'm going to give you numbers like this. Ignore this. Scratch through it. So ignore that. That's done. That was an example. We already did it. I'm going to give you this. So now I'm going to give you something in a different format. Instead of giving you something in this format, I've given you this format. And I'm going to ask you to move it into this format. I'm not even going to do that. I'm assuming if you can do this one, you can do that one. It's just a matter of then putting parentheses around the correct things. So we're going to move it from this now into this. Because again, this matches up, right? We don't have any radical symbol. The only one that doesn't have a radical symbol is this first version. So it's got to be this version that we're looking at. So you could do the same thing. Label these things here with all of the different names. So again, the big number or the base, I really should be saying base, but next week maybe we'll say base more often. So that 15 is a big number. Obviously top and bottom number in this format shouldn't be real tough to figure out because it's literally the top number and the bottom number on the exponent. So label them there. Now say, okay, well, where do I put stuff? Well, I got to draw the radical symbol first. So what goes first under there, do you think, under the radical symbol? Yeah, the big number. We don't put an exponent first. We'd always start with the base. What goes with the base underneath the radical symbol? So the top number, right? So top number. So again, if I'm not sure, I'm thinking, okay, I need to write it like this. So I need a top number. Well, I've written top right next to my number already. So that's easy. And then what goes on the outside? Yeah, I need a bottom number. Well, where's the bottom number? Oh, well, I labeled that the bottom number right there. So forth. That's it. I mean, that's the only new part. It's not really new. We're just going the other direction. So I'm going to do one more, and then I think we're good, unless anybody wants additional ones.
Can I put this up?
Just wait a second, since we're almost done with this. Is the last one. So I'm going to give you one with variables now that you have to turn again in this format. I'm going to go with raised to the, so there. So that is a B, correct? That is the variable B. It's raised to the B over A. Yeah, I don't know how to say that. It's hard to say. It's raised to the, yeah, I don't know how to say that. Like it's got to be the B. Like it's not. You can't say fifth or sixth or anything. It's got to be to the B over A power. I don't know. Yeah.
Taylor, you can come.
Where?
Where's the football bag? Yes, you do. The black bag that you bring out there.
Oh, I don't have that.
Where is it?
My house.
My Apple Watch is in there.
All right, I got an Apple
No,
Watch.
you don't.
Yay! I mean, no, I didn't see an Apple Watch in there. I looked all through it.
Are you serious? I put my Apple Watch in there yesterday.
I don't know where you put it. I didn't see one. I mean, I didn't look through it, so I'm assuming it's still in there. But
It is.
yeah, it's my house.
Where's my game
I got
case?
all kind of stuff with flag football. I got an Apple Watch now. I got a nice shirt. I got a
You
nice
don't
hoodie.
have the
I got
Apple
all
Watch.
kind of
You
stuff.
Give me my hoodie too.
It's
That
not
red
your
one that
hoodie,
says
that's
Nike on
Jayla's
it, it's
hoodie.
mine.
It's the red one?
Yeah, if
Jayla
it says
said it was
Nike
hers.
on it, that's mine.
Jayla said it was hers, so
It's
that's
a
why I'm
lie.
giving it back to you.
No, you're
She was
not.
wearing it the day that I took it.
Because you're not dress coded.
I'm just saying.
I need my Apple Watch and my hoodie.
She is the
Thank
one
you.
that gave me the hoodie. So it's her hoodie as far as I'm concerned. All right, so now we're moving it over. First thing we do, write a radical sign. What would you say the next thing that we, oh wait, what could we also do before we even did the radical sign? If we want to, we don't have to. We could label these if you want. So if you're struggling with this at all, you don't have to, but again, you could say, well, that's going to be my big number, top number, bottom number. I'm just saying, hey, I hope everybody gets 100, but I would bet not everybody gets 100. Because somebody always makes a simple mistake. Because they don't follow the process. They think they got it down, and they wind up putting something wrong. I hope everybody gets 100. But I'm just telling you, I've been doing this for a lot of years. What's the, you tell me the answer, and then I'll let you go do that.
In.
Where?
Under the line.
Two things go under there. So is it the big one or the little one? I'm assuming you mean like that. All right, that's it. That's your exit ticket. I did not put in. I was going to put some of the stuff we did today on there. And I'm like, you know what? We had a short week. You didn't have Monday. So we lost the, even though it was only 1/2 of a period, really. I still just said, I'll just make this one this one. 50, 47.
Yeah.
Well, that's calm down. You do a lot in 40 minutes. Was somebody else waiting for that?
No.
All right, go fast though, because I'm about to give out the exit ticket. So I need your phone. I don't have a pass, so well, I guess I could write a pass real quick right now. No, oh no, I think I do have an old blue pass that I saved. Can't believe that. This is on my pass. This one I kept, one of those things, because I knew I'd wind up losing. Oh, all right, I gotta write another one, so hold on. So, just don't do phones yet, because I'm about to pass it out. I'll put it right back up as soon as I write this bathroom pass. And then after we're done, and I've taken it, and I said, yeah, that's, you know, that looks like you're done. I'm not going to grade them, but I'll look at it and just make sure it looks like you've done everything fairly correctly. I mean, you use them on the exit ticket, but yeah, if you don't need it anymore. I was trying to figure out what to do, if I was going to make it today's date or just for the day. So now I'll take phones for this, I guess, for a while. Yeah. All right, so we'll try to take care of that. It's going to wrinkle pretty quickly otherwise. Did you give me your phone?
Put it out my head.
No, actually give it to me because this is what I was doing to get the pass back, and then as soon as I stopped doing it, I didn't get the pass back. Yeah, I mean, literally the first person that I didn't take the phone from today because we were already done, and I had said they could have their phones out, and he didn't bring it. All right, you ready? Let's go. Let's go. Should be fast. Again, once you're done, take your time though. Don't like rush through it and do a careless mistake. Like once you're done, maybe you take a quick break from it and then come back and look at it real quick again. Just make sure. It would be a shame to not get a 100% on something that is. Like I said, I hope everybody does, but somebody always makes a silly mistake sometimes. They try to do it too fast. So if I'll just tell you the first three are like what we did. Well, actually, no, that's not right. I take that back. It's actually in the other order. The first three are what we did here. And you might have different numbers, but it should still be in the same spots. The first three are this in blue. The last three are this one over here, where you take this and you move it into
Just to make sure we're just doing like the opposite, you know, like how you're doing.
yeah, just put the big numbers where the big numbers should be. That's what you're doing. So then this is the other one. So this will be m to the n over a. So I went from this to this, but over here I went from this to that. Some of you will be done like 2 minutes. Yeah, today's 24th. Once I've taken it from you, you can jump on your phones. Should be quiet though when you're on your phone. There shouldn't be reason for it to get loud. Certainly not while people are still finishing. Just the opposite. So you up here you took that and put it in that format. Now you can have one with a radical, so you're putting it in a format like these. So just like this one here. So you're going from this. Are you good? You're going from this to something like this. You can, yeah. If I've taken your exit ticket, you go ahead and put it, but it needs to be quiet here. And let you use phones, you know, reason for it to get loud. Not while people are finishing. I mean, it shouldn't get loud anyway.